Hi everyone, good morning all of you, myself N. Suresh. In this PPT, let us discuss about the environmental pollution. And environmental pollution, we have to discuss about air pollutants, the sources, effects and the control of primary air pollutants like carbon monoxide, oxides of nitrogen, NO and NO2, oxides of sulfur, SO2, SO3, hydrocarbons and particulate matters. Environmental pollution. We are all familiar with the word environmental pollution because of our activities or due to natural calamities. Our environment is getting polluted day by day to the larger extent, which can be defined as the excessive discharge of undesirable substances into the environment, thereby adversely affecting the natural quality of the environment and causing damage to human or plant or animal life. There are different types of pollutions like air pollution, water pollution, soil pollution, light pollution and noise pollution, etc. The air pollution is because of the excessive discharge of unwanted gases like oxides of carbon, oxides of sulfur, oxides of nitrogen, etc. from the factories or from the vehicles, affecting the quality of air in the atmosphere. It is called air pollution. Water pollution is because of the discharging of unwanted materials into the water. In the factory, we use lots of chemicals like acids or bases or salts, etc. in order to manufacture some desired products. After obtaining the desired products in the factory, the waste, industrial waste, simply we are dumping into the nearby water streams, either it may be lake or river, causing its pollution. Domestic waste also we are discharging into nearby water streams, causing the water pollution. It is called water pollution. Soil pollution is because of excessive discharge of the chemicals like pesticides, insecticides, chemical fertilizers using for agricultural purpose, dyes, detergents using for domestic purpose, etc. Especially the solid waste we are dumping into the soil, affecting its qualities. It is called soil pollution. Light pollution is because of using high intensity lights in the automobiles and also using crackers to celebrate Deepavali. It leads to light pollution. Noise pollution is because of unwanted sound from the vehicles or unwanted sound from the factories, etc., causing noise pollution. These are different types of the pollutions. Now let us see about primary air pollutants. Primary air pollutants are those that directly emitted into the atmosphere through natural or human activities. Example, sulfur dioxide, oxides of nitrogen, NO, NO2, oxides of carbon, carbon monoxide, carbon dioxide. These unwanted gas, they will emit into the atmosphere directly through human activities or through natural calamities. Oxides of carbon, carbon monoxide. Carbon monoxide is one of the most serious air pollutants, which is colorless, odorless, highly poisonous because of its ability to block the delivery of oxygen to the organs and tissues in our body. The main sources of carbon monoxide is partial combustion of fuel in automobiles and industries. In automobiles and industries, we use fuels. If the fuel undergoes incomplete combustion, then there will be the emission of carbon monoxide into the atmosphere. Smoking and domestic heat appliances. Domestic heat appliances like burning LPG gas or burning fire woods, if it undergoes incomplete combustion, there also the emission of carbon monoxide. During smoking also there will be emission of carbon monoxide into the atmosphere. Natural processes such as forest firing, volcanic actions, mass gas production, they also contribute the carbon monoxide into the atmosphere. So carbon reacts with oxygen, gives carbon monoxide. What are the effects of carbon monoxide? Normally, 0 to 0.5 ppm of carbon monoxide in the atmosphere with no risk. The main problem effect of carbon monoxide is it binds to the hemoglobin to form carboxyhemoglobin complex which is about 300 times more stable than oxygen hemoglobin complex. We knew the hemoglobin, it binds with the oxygen and carries oxygen to the tissues, organs in our body. This ability of hemoglobin to carry oxygen in our body, it will be reduced by carbon monoxide, because carbon monoxide form complex, a strong complex with hemoglobin, which is called carboxy hemoglobin complex, 300 times more stable than oxygen hemoglobin complex. If the concentration of carbon monoxide in the atmosphere is more than the permissible limits, then it results in headache, weak eyesight, nervousness, paralysis, vomiting, and other cardiovascular diseases. Then how to control the release of carbon monoxide into the atmosphere? Yes, it is possible. We can control by developing exhaust systems which will complete the combustion process. We have to develop the exhaust systems. There, the fuel must undergo complete combustion. If the fuel undergoes complete combustion, then there will be the chances of reducing the emission of carbon monoxide into the atmosphere. Developing pollution-free power sources like fuel cell, by the use of fuel cell in automobiles instead of this internal combustion engines, we can reduce the emission of carbon monoxide into the atmosphere. Fixing catalytic converter in the exhaust of automobiles, as nowadays in all automobiles there is a catalyst is fixed, which is called three-way catalyst, which converts the carbon monoxide into carbon dioxide. So by fixing catalytic converter in the exhaust of automobiles, we can reduce the emission of carbon monoxide into the. The effect of carbon monoxide on health, it depends on the concentration of carbon monoxide and how long the person exposed to that concentration. If the percentage is 9 ppm, then the maximum allowance for the is up to 8 hours continuous exposure. If its concentration is 50 ppm, then maximum allowance for continuous exposure is for 3 hours. If it is 100 ppm concentration, then the maximum exposure is for 100 minutes. If it is crosses 200 ppm, then it causes slight headache, tiredness, dizziness, nausea in 2 to 3 hours. If its concentration is 400 ppm, then it leads to some heavier headache in 1 to 2 hours. If its concentration is 800 ppm, then it causes dizziness, nausea in just 5 minutes. If its concentration is 1600 ppm, it may lead to death in just 1 hour of time. If its concentration is too high, up to 6400 ppm, then it leads to death in just 15 minutes. So this is the effect of carbon monoxide on the health. However, the effect can vary depending on the age, sex, weight, and overall health of the human beings. Now let us see the oxides of sulfur. Sulfur dioxide and sulfur trioxide are the common oxides of sulfur. The release of sulfur dioxide and sulfur trioxide into the atmosphere, it will affect the natural quality of air. Then what are the sources? Burning of sulfur containing fossil fuels like coal and petrol. During obtaining petrol or diesel from crude petroleum oil, we use sulfur for chemical processing. So therefore, by burning the sulfur containing fuels like coal or petroleum, there will be the chance of releasing sulfur dioxide and sulfur trioxide into the atmosphere. Petroleum industries, oil refineries, sulfuric acid plants, in all these factories, so there will be elimination of sulfur dioxide and sulfur trioxide directly into the atmosphere. Processing and smelting of sulfide ores like lead sulfide and mercury sulfide. So we use these ores of metal Ores of lead is lead sulfide. Ore of mercury is mercuric sulfide. To obtain the metals during metallurgical process, so if we use their sulfide ores, then there also the elimination of sulfur dioxide and sulfur trioxide into the atmosphere. Sulfur reacts with oxygen giving sulfur dioxide. This sulfur dioxide reacts with oxygen giving sulfur trioxide. Both sulfur dioxide and sulfur trioxide will be released into the atmosphere due to these sources. Effects. According to WHO, the permissible limit of sulfur dioxide in air is 20 microgram per cubic meter of air volume. It is a 24-hour mean. Sulfur dioxide is poisonous to both the animals and plants. It has been reported that even a low concentration up to 1 ppm sulfur dioxide causes respiratory diseases, eye irritation, damages cells, membranes, stone leprosy, yellowing of paper, corrosion of metals, etc. If the concentration is more than 20 microgram per meter cube in the atmosphere, then it leads all problems. Sulfur dioxide is highly soluble in water giving sulfuric acid, which is a main component of acid rain. So sulfur dioxide reacts with oxygen, gives this compound. This compound reacts with water, gives sulfuric acid mist. It may also lead to the acid rain. Then how to control the release of sulfur dioxide and sulfur trioxide into the atmosphere? It can be controlled by absorbing sulfur dioxide on a suitable adsorbent like sodium oxide, aluminum oxide. When sulfur dioxide is exposed to this material, sodium oxide and aluminum oxide, this reacts with sulfur dioxide and giving a stable sodium sulfate and aluminum sulfite. So we can reduce the release of sulfur dioxide into the atmosphere by allowing it to adsorb on this compound. Using natural gas instead of high sulfur fuel like coal and petrol, emission of oxides of sulfur can be reduced. Instead of using the sulfur containing fuels, if we use a natural gas, we can reduce the emission of oxides of sulfur into the atmosphere. Passing sulfur dioxide through a slurry of calcium carbonate to form calcium sulfide, then inject air to this reaction mixture to oxidize calcium sulfide to calcium sulfate, stable calcium sulfate. Sulfur dioxide is passed through a slurry of calcium carbonate. It leads to the formation of calcium sulfide. Then oxygen is blown into this mixture to convert calcium sulfide into a stable calcium sulfate. In this way, we can reduce the release of oxides of sulfur into the atmosphere. Oxides of nitrogen. Nitric oxide NO and nitrogen dioxide NO are the common oxides of nitrogen. The release of oxides of nitrogen into the atmosphere, it also affects the natural quality of air, causing the environmental pollution, air pollution. The sources of NO and NO2 are natural processes like lightning and volcano. During lightning and volcano also nitrogen dioxide will be released into the atmosphere. Nitrogen reacts with oxygen giving NO at about 1483 Kelvin during lightning. This NO later reacts with oxygen giving nitrogen dioxide. Combustion of coal, oil, natural gas and gasoline. Incomplete combustion, it also will lead to the release of oxides of nitrogen into the atmosphere. Denitrifying bacteria in soil produces NO2. In the soil also the natural bacteria during denitrification it releases N2O into the atmosphere. So effects, what are the effects? The permissible limit of NO2 should be less than 40 microgram per meter cube annual mean. High level of NO2 in air causes eye irritation, damages lungs. If the concentration of NO2 is more than the permissible limit, then it causes eye irritation, it damages lungs, etc. NO2 reacts with atmospheric water and forms acid rain. NO2 reacts with water gives HNO2. This HNO2 reacts with oxygen gives HNO3. So which is forms acid rain. In presence of sunlight, NO2 forms ozone which damages mucous membrane and the respiratory tract. NO2 in the presence of sunlight, it will absorb UV radiations and convert it into nitrous oxide. This nitrous oxide uh, reacting with and giving this oxygen reacts with the oxygen molecule giving ozone. On the surface of Earth, there is a high concentration of ozone. It damages mucous membrane and the respiratory tract. Nitrogen oxides and hydrocarbons form photochemical smog, which causes asthma, bronchitis, high irritation, and chlorosis. Oxides of nitrogen reacts with the hydrocarbons in the presence of oxygen and sunlight. It leads to the formation of photochemical smog. In the photochemical smog, the main element is peroxyacetyl nitrate. If the peroxyacetyl nitrate concentration is more, then it causes high irritation, asthma, bronchitis, chlorosis, etc. Therefore, it is inevitable for us to reduce the concentration of oxides of nitrogen in the atmosphere. How to control? The release of NO and NO2 can be prevented by treating the flue gas, waste gas containing oxides of nitrogen with ammonia in presence of vanadium catalyst. NO present in the flue gas reacts with ammonia to form N2 and H2O. Nitric oxide is made to react with ammonia in presence of oxygen and in the presence of vanadium catalyst. So this nitric oxide will be reduced into nitrogen and water. We can reduce the concentration of this one released into the atmosphere. Oxides of nitrogen can be removed by treating the flue gas with sorbents like powdered limestone or aluminum oxide. By passing these oxides of nitrogen through the sorbents like limestone and aluminum oxide, so then we can reduce the release of oxides of nitrogen into the atmosphere. Oxides of nitrogen present in automobile exhaust released through the automobile exhaust into the atmosphere can be reduced by fixing catalytic converter in the exhaust of automobiles. That catalytic converter fixed in the exhaust of automobiles that also converts the oxides of nitrogen into nitrogen gas and oxygen gas. Therefore, by fixing catalytic converter, the release of oxides of nitrogen into the atmosphere through the exhaust can be reduced. Hydrocarbons. Hydrocarbons presence in the atmosphere, it also affects the natural quality of air. Hydrocarbons are composed of hydrogen and carbon. The main sources of hydrocarbons they are formed by incomplete combustion of fuels used in automobiles and industries. The hydrocarbons found in atmosphere, normally they are methane, ethane, propane, toluene, etc. In industry and automobiles, we use fuels. If these fuels undergo incomplete combustion, then unburnt hydrocarbons will release into the atmosphere. Methane is a major hydrocarbon formed by bacterial decomposition of organic matter in water and sediments. In water and sediments, methane also will be formed because of this reaction. So it undergoes the reaction giving carbon dioxide and methane. Effects. What are the effects of hydrocarbon? Methane is called greenhouse gas, causes global warming. It is a greenhouse gas. It increases the temperature on the surface of Earth, causing a global warming. Hydrocarbons inhalation causes irritation to mucous membrane and affect nervous system. If there is a high concentration of hydrocarbon, if we inhale, so it leads to high irritation and it affects the mucous membrane, it affects the central nervous system. Hydrocarbons at high concentration causes carcinogenic effects on lungs. It causes carcinogenic effect on skins and also on lungs. Hydrocarbons in presence of sunlight form photochemical smog which causes eye irritation and cracking of rubber. So already we discussed about this one, photochemical smog. So high concentration of hydrocarbons in the presence of sunlight and oxygen and oxides of nitrogen, it will form photochemical smog. In the photochemical smog, PAN, peroxynitrile compound is the major compound. If this concentration is more in the atmosphere, then it causes high irritation, cracking of rubber, asthma, etc. Hydrocarbons harm plants. They will affect plants by causing aging, breaking down of tissues, and the shedding of leaves and flowers. These are the effects of hydrocarbons in the atmosphere. Control. How to control the hydrocarbons? Unburnt hydrocarbons present in the atmosphere. Automobile exhaust can be converted into carbon dioxide and water by installing catalytic converter in the exhaust of automobiles. A three-way catalyst fixed in the exhaust of automobiles that also converts unburnt hydrocarbons into carbon dioxide and water. Not only the catalytic converter to the automobiles, this catalytic converter should be fixed to the chimneys of factories also. In the factories also, there will be the emission of unburnt hydrocarbons into the atmosphere. By fixing this catalytic converter into the chimneys of factories, so we can convert the unburnt hydrocarbons into carbon dioxide and water. Thereby, we can reduce the concentration of hydrocarbons in the atmosphere. The polluted air is passed through the porous solid adsorbents kept in suitable containers. The hydrocarbon pollutants are adsorbed at the surface of the porous solid and clean air passes through. By passing the flue air, this containing unburnt hydrocarbons through the solid adsorbent, so the gases, the hydrocarbons will be adsorbed on the surface of these adsorbents and clean air can be released into the atmosphere. Particulate matter. It is also one of the serious air pollutant. A finely divided solid particles or liquid droplets suspended in air are called particulate matters or particulates. I'll repeat, finely divided solid particles in fine form, or the liquid droplets suspended in air are called particulates. Particulates with less than 2.5 micrometer in size are called fine particulate matters, and if their size is greater than 2.5 micrometer, they are called coarse particulates. Particulates in the atmosphere, they are maybe viable or non-viable. The viable particulates are minute living organisms that are dispersed in the atmosphere. They are bacteria, fungi, molds, algae, viruses, etc. And the permissible limit is less than 10 microgram per cubic meter for fine particulate matter, and it is less than 20 microgram per meter cube for coarse particulate matter, annual mean. The main sources of non-viable particulate matters are smoke, dust, mist, spray, fumes, etc. are the non-viable particulates, and their sources are: the source of smoke is formed during the combustion of organic matter. By burning during the combustion of any organic matter, there will be the production of the smoke. Examples are cigarette smoking, smoke from burning of fossil fuels, garbage, dry leaves, oil, smoke, etc. So during burning or smoking of these things, so there will be the production of smoke into the atmosphere. Dust will be released into the atmosphere during crushing and grinding of solid materials. Sand from during sand blasting gives fine particles of sand. Sawdust from woodworking, pulverized coal, cement, fly ashes from factories, dust storms, etc. They emit dust particles into the atmosphere. Mist formed by the condensation of vapor, dispersion of liquids. During dispersion of liquids and condensation of vapor, mist will be formed. Spray formed during atomization of droplets. During atomization of droplets, so as spray will be formed. Fumes, condensation of vapor by sublimation, distillation, calcination, etc. Whatever the fumes produce, so it emits a particulate matter into the atmosphere. The effects of particulate matter. Particulate matter with a diameter of 10 microns or less can penetrate and lodge inside the lungs. It affects the lungs. Particulate matter with 10 microns or less, they even can penetrate and lodge inside the lungs. They cause respiratory problems there, reduction of visibility, sneezing, lung cancer, coughing, nose blocking, and asthma, etc. So particulate matter with the 10 microns, they will penetrate inside and they will lodge in the lungs and causes these problems. So particulate matters also will cause eye irritation, nose problem, throat irritation, etc. Then how to control the concentration of this particulate matter in the atmosphere? There are many techniques developed for the control of particulates. In the examination, if this question is asked, so here I have explained four techniques. Any one, if we explain, that's enough for the sake of marks. Gravity settling chamber. In the gravity settling chamber, it is the oldest and simplest means of removing suspended particles of size greater than 50 micrometer from flue gas. The flue gas containing particulate matters is passed through the gravity settling chamber at high speed. When the flue gas containing the particulate matter is passed inside this gravity settling chamber, the gas stream enters the chamber where the velocity inside this one is reduced, and the solid particles or the particulate matters present in the flue gas, they will move downwards through the gravitational force and they will collect at the bottom, and the clean gas can be released into the atmosphere. This is the simplest and oldest method. Method is wet scrubber. This is more advantageous. In the wet scrubber, pass the flue gas containing particulates, pass the flue gas containing particulate matter through the chamber and over this spray water. The particulates present in the flue gas are captured by the water droplets and they will collect at the bottom of the chamber, and the clean gas can be released into the atmosphere. Any mist associated with the air, it can be eliminated by passing the air through mist eliminator. In this method, particles of size from 0.1 to 200 micrometer can be removed efficiently. So wet scrubber, in the wet scrubber, the flue gas containing the particulate matter is passed, is blown inside the wet scrubber from the bottom. When the gases rises up, over this gas, water is sprayed. When water is sprayed, the particulate matter, they will attracted by the water molecules and they will collect at the bottom. They move downwards and collect at the bottom. The flue gas, if it is associated with any mist, the mist can be eliminated by passing it through the mist eliminator, and the clean gas can be released into the atmosphere. Next method is a fabric filter. In the fabric filter, the flue gas containing the particulate matter is blown inside this fabric filter. When it is blown inside this fabric filter contains porous structured fibrous material. A filter bag is there. In these filters, there are porous. Their size is very small when compared to the size of particulate matter. Therefore, when the flue gas containing the particulates is blown inside, the gas rises up and passes through these filters. When the gas passes through this filter, the particulates, they will be collected in these filters and then they move downwards due to gravitational force and they will collect at the bottom, and the clean air, it will passes through the pores of this filter and can be released into the atmosphere. Fabric filters can provide about 99% efficiency for particle separation. From this method, up to 99% efficiency, we can remove the particulate matters present in the flue gas. It's a very important method, that is the electrostatic precipitator. Electrostatic precipitator. So look at this diagram. This is a simple diagram of electrostatic precipitator. This in this electrostatic precipitator, there are two electrodes. One is the positive electrode. It is in the plate form. It is called also collector. And in the middle there is a negative electrode. It is called discharging electrode. This negative electrode is in the form of a thin wire in the middle of the positive electrodes. On either side there is a positive electrode in the form of plate. And these two electrodes are connected to high tension battery of about 50,000 volt. Because of high negativity potential at the negative electrode, the air molecules in between these electrodes undergo ionization, giving electrons. So because of high potential, so between the electrodes, in between the negative and positive electrodes, the air molecules, they undergo ionization, giving electrons. When the flue gas containing particulate is blown inside this chamber, electrostatic precipitator, the particulate matters, the particulates present in the flue gas, they will be collide with the electrons. They will collide with the electrons and they become negatively charged. The particulates present in the flue gas, they will collide with the electrons and they will become negatively charged. When they become negatively charged, these particles, they will attracted by the positive electrode kept on either side. So that the particulates, they will become negatively charged and they will be deposited on the surface of this positive electrode. Therefore, it is called collector. Particles then fall due to gravitational force and the flue gas become almost free from ash or dust, can be discharged into the atmosphere. Clean gas can be released into the atmosphere. So this type of electrostatic precipitators can be fixed into the chimneys of factories to reduce the emission, the release of particulate matter into the atmosphere. The smoke present in the ash or dust, it is called flue gas. I will repeat once again. So this electrostatic precipitator contains two electrodes, the positive plate electrode, which is called collector, and the negative electrode, it is called discharging electrode, which is in the form of a thin wire connected to high tension battery of about 50,000 volt. Because of high potential, the air in between the electrodes undergo ionization, giving electrons. At this stage, when the flue gas containing the particulates is blown inside, the particulates, they will collide with the electrons and become negatively charged. When they become negatively charged, they will attract by these positive electrodes and it will collect on these collectors, and later due to gravitational force, so they will move downwards and collect at the bottom. The clean air, after removing the particulates, the clean air can be released into the atmosphere. Like this, we can reduce the release of particulates into the atmosphere by using any one of these techniques. See what this video, when the dirty air containing particulates is passed through this electrode, so they will attracted by the electrons, they will convert it into negatively charges. These negatively charges, they will be attracted by the positive electrode and the clean air can be released into the atmosphere. Thank you.